Okay, another video. Here we go. Okay, so this one, hopefully, yeah, something. I think this looks more like the test. Definitely more like the test. Definitely. Okay, so we're gonna do some factoring there to get our asymptotes. Let's see here. So let's go ahead and change over now to blue. And so x squared plus x minus 6, right? So it's gonna factor. What is it gonna factor into? So x and x, and then what? 2 and 3? With a positive 3. So positive 3 and a negative 2. That'll work because 3 minus 2 is 1, and that's the number right there. And then bottom, factors of 12 are 3 and 4. Good. Plus and plus. Cool. We do have something cancels, and that's our whole. So at x plus 3, which is actually going to be x equals opposite sign, so negative 3 is our whole. So don't forget to graph our whole, man. So then we're just left with x minus 2 over x plus 4. So the vertical will be the bottom, x plus 4. So we just set that equal to 0, and we get a negative 4. And then on the top, we have x minus 2. Set that equal to 0, and we get a positive 2. There we go. So we have a horizontal asymptote at 2. That didn't break up very well. And then we have a vertical asymptote at negative 4. So negative 4 vertical. Cool. Now we want to graph this sucker, so we need an intercept. So where's our intercept? Well, to find the x equal to 0, remember that it's right. Go ahead and so then we did have, oh, I screwed up. Where'd you screw up, Newbold? I screwed up on the horizontal asymptote, the ha. Sorry. So that's actually the x-intercept, right? Wah, wah. So that's actually the x-intercept. So the x-intercept is x equals 2. And what is the horizontal asymptote, or how do you find the horizontal asymptote? Oh, so that's the powers. Remember powers? Horizontal asymptote is the powers. And so powers are the same, so we just use the numbers in front, 1 over 1. So we need to shift it down to 1. We can do it. You got this. I got it. Sorry about that. I do apologize. So we changed our horizontal asymptote to be y equals 1. Fixed it. It's okay to make mistakes. Everybody has those days. You just got to fix it. Okay, so that means that x equals 2. We have a x-intercept. So that's along the x-axis right there. And then to find the y-intercept, where it crosses on the y-axis, we just set x equal to 0. And so our original problem, after we crossed out the x plus 3's, was, remember, it was x minus 2 over x plus 4. And so when we go ahead and set those, the x is equal to 0, we're just left with negative 2/4, or negative 1/2, which is down here. And so that proves to us that definitely, that our graph is going to go along this asymptote through our y-intercept and x-intercept, and then along the other asymptote. And then usually, most likely, almost always diagonal that, so that's in this direction, is going to be where our other graph is. Cool. There we go. So there's number 14 to help you on graphing review. For graph number 15 on the left, name each of the following. So the y-intercept is down here at negative 4. The roots is where it crosses or touches on the x-axis, so negative 1, 2, and 4. So roots are at negative 1, 2, and 4. Ace it on the test. Our multiplicities now, so that means our multiplicities at negative 1. So it would be, so it's already kind of listed there, right? So at negative 1, our multiplicities is a bounce, so that's a squared. At x equals 2, it's a wiggles through, so that's a 1. No, wiggles through could be 3 or 5. And then at 4, it is going to be a 1 because it crosses straight through. There's our multiplicities. Now just to show you what I mean, this is our graph. And so at x, so that negative 1 there, should we draw a line? So that negative 1 becomes a positive 1 to the squared power because it bounces at negative 1. And then at the next one, which is x equals, or x, that's a positive 2, so it'll be a negative 2. That'll be to that wiggles through, so probably the third or maybe even the fifth. And then our last one is going to be x minus 4 to the first power. So that's what we mean by multiplicities and the roots. Okay, and behavior, both going down. Both going down, 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 down. If you want to do the whole thing there, you do as x goes left, negative infinity, y goes to positive infinity. And as x goes to right, positive infinity, y goes to positive infinity. Oh, what the? Negative infinity, Newbold. Sorry. So negative infinity because our graph is definitely going down, down. Even in odd degree. So odd degree would be opposite directions, but this, of course, is both going down with our end behavior. So that means it's going to be an even degree polynomial, probably something like x to the 4th or 6th or 8th. Beautiful. That's number 15. Cool. We made it. So basically, these ones I can do in class, not so much. It's just you can make up your own thing. Draw the parent function, then label what each variable represents. So m equals the slope, remember linear, and b equals y-intercept. And so this is you can just graph your own thing there if you want. Parent function would just be y equals x, which just goes right through the center, 0, 0. So that's called the vertex. And so a would be our slope. H would be our x value of our vertex, right? And then the k would be the y value, right? The y value of our vertex. And so, for example, let's say that a is 1, and h is maybe 2, and k is 3. So this is just like an example. So we had y equals 1, then we have x minus the 2 all squared, and then let's say plus 3. So this would be a parabola or a quadratic. The parent function's like this, right? And then the shifting going on here is going to be not right 2, but careful now, left 2 and up 3. So we go left 2, up 1, 2, 3. And so this is our new function going in this direction and going up in this direction. And so that's for quadratic. Quadratic. Okay, then don't forget our square root. Yay. So don't forget our absolute value and square root. What the? Okay, so again, a is always like the slope or the expander. Makes it go up or down or narrower or faster. The h value, again, is our shifting to the right or to the left. Right? Or left. And k is our up or down. We've already kind of talked about these here. Right or left, up or down. Remember the inside, this works for all of them. So remember for the inside, it's actually opposite, right? It's opposite what you think. So I'm going to put that here for the h value. So h value, don't forget, it's opposite of what you think. Write this down. So opposite direction. Now we've already done enough of these that I'm not going to do any more examples because I know you just love watching these videos. And so we've already gone through and done all those. So I think I'd want to go home, Newbold. Yeah, so again, right, left, up or down, right, left, up or down, slope. So same kind of thing. You can just go back and watch my cubic, absolute, and all those things. But thanks for watching and acing our final semester exam coming up next time. Or 2 times if we have to do the practice test though. Beautiful. Thanks for watching. Appreciate you. And shout out to Brecklin for saying she'll get all of her friends to subscribe to my channel if I make all these graphing videos. Alrighty then, Peyton. Alrighty then. Isn't that something special? So thanks for watching. Peace out. Thanks for watching.